let me go back into the course website first and kind of let you guys know where the homework is. Well, right here, there's a little bit about security that you can, kind of pay attention to. Is how I use HTTPS instead of HTTP to the Moodle website. In fact, if you want to, you can try to use HTTP instead of HTTPS. And if you press the Enter key, you can see that when you use HTTP without the secure part, it goes to a different web page because I configured the server to do that. So it forces you to use HTTPS in order to make a connection to the Moodle server. So this way, when you log in, like right now, when I log in using my username and my password, those two parameters would not be passed by plain text anymore. So even if someone is sniffing the traffic, they will only see the encrypted version of the transmission of this page or this form and not in plain text. So that's one thing that you can also make sure when you do anything on a computer, on a client computer, and it's not Linux specific. This is basically universal to any type of operating system that you use. It's also universal to any type of browser that you use. Okay. If I remember correctly, I think Google with Gmail is now also using only HTTPS connections. So you cannot use HTTP with Gmail anymore. It's always going to use HTTPS. Can anyone think of a downside of using HTTPS instead of HTTP? Slower, exactly. So if you have a computer, and I cannot log in. Oh, I see why. There we go. There we go. Okay. So never, save the password. I'm using a live distribution right now, so I'm not actually saving anything other than onto the RAM drive. But I won't even do that, because it's just not a good idea. When I was talking about certain things with one of the students here, the question came up of, how do you keep track of all the passwords? Okay. I'm pretty sure most of you do not use the same password for all the websites that you go to. Okay. So now, how many passwords do you have to keep track of? Quite a few, right? Okay. So with that many passwords, sometimes you cannot remember, what password you use on a website that you don't use for months. Okay, you set it up, a few months ago, and now you have to go back to that website, and you have no idea what you use for your password. For the most part, there's usually a feature to reset a password, which is okay, but you kind of get tired of having to reset your password every single time you get to a certain website. So the question now is, what is the best way to keep track of your passwords? Password manager on a cell phone? I would not do that. I would not do that for a few reasons. Okay, so let's think about what can potentially happen when you download an app that is what they call as a key save or key password manager. One thing that can happen is the developer potentially can get your password, right? Because they know the password that you use for unlocking the key store, and once that is known, the actual content in the key store is also insecure. So that's one reason. And then the second reason is if you store anything on your device and your device is network connected, it is possible for someone to attack your device through the network, and as a result, whatever you store on the device itself can be lost as well. Okay. What I usually tell people to do, sounds really, really dumb, but if you think about it, it's not really as dumb as, it's not as, exposed as some of the other ideas. You write it down on a piece of paper or on an actual physical notebook. Now, that doesn't sound very smart, does it? But if you think about it, how many people have, potentially network access to your mobile device? Okay? You're on 4G, you're on Wi-Fi, okay, and so potentially it can be a lot of people, right? Some people who you never meet also because it's just the network. How many people can have physical access to a little booklet that you have that write down all your passwords? Well, just people that you can see, right? People around you, people that you can see. So if you think about it that way, the exposure of that little booklet with all your passwords actually has a lot less exposure compared to storing something on a network-enabled device. Is that making any sense? Okay. Now, it doesn't mean that you have to write down your password exactly the way they're supposed to be, right? So what you can do is you can write down your passwords, backwards. You can have, alternating characters. So you put down all the characters at odd positions first, 1, 3, 5, 7, 9, and then you write down all the words, in the opposite, in the even positions. So you can come up with your own way to kind of, change the pattern so that you know how to read from your own booklet to find out the actual password. But the next person will have to kind of go, okay, they will type it in the way it is specified in your little notebook, but it's not going to work because it's not the right order of reading those characters. So there are ways to kind of make it a slightly more secure, but the whole point is if it is physical, it's harder for someone to get to. No one can get to it through the network. They have to be physically next to you to actually see it. Okay. So that's my reasoning of actually writing down the password on a little notebook so that people cannot take your password, and yet you can keep track of multiple password for multiple websites in a slightly convenient way instead of having to reset the password all the time because you cannot remember anything. Okay, is that making any sense? Sort of. Yep.
That's like encryption.
It's kind of like encryption, but it's not encryption. It's more like obfuscation. You're just using obscurity for security. But still, it's the whole point of a physical book is the physical access as the physical access aspect of it. It's not network reachable anymore. It's actually a physical thing that you keep around you. All right. But that part is not Linux specific. All right. So what I'm doing now is I'm going to the to my website and show you guys how to find the homework assignment. So right now the homework assignment is to set up VirtualBox, and it's in topic 1, and you can see what it looks like. It has a little check symbol here, but it does not show up on the calendar because I did not set up a deadline to do it. So maybe it is best if I set up a deadline first. Okay, so I go ahead and set up a deadline, and I think we can set up a deadline of maybe a week. I don't think it will take you guys a week to install VirtualBox and to test it. So what I'll do is I'm going to set up a week, open the quiz. It's already open, but I will close the quiz on a particular date. So today is the 27th. I'm going to close it on the 3rd of April. And we're going to pick the start time of this class as the closing date and time. I'm not going to put a time limit, which means you can still do it. You can open the quote-unquote quiz and do one question for 2 hours. Go do something else, come back a day later, and then do the second question. Okay, so that means there's no time limitation. It is still in the form of a homework assignment instead of an actual quiz. So I'll go ahead and save it and return to course. So now you have your, now it will show up on the calendar, because if you look at the calendar and you go to April 3rd, now it says setup VirtualBox is going to close on that day. Okay. Are there any questions about how to find your homework assignments? No questions? Go ahead.
Will all the homework assignments look like how it is right now? It's got a piece of paper and a red check mark instead of VirtualBox. It kind of look like that.
That's actually what a quiz looks like.
Okay.
A homework assignment looks like a hand with a piece of paper on it.
Oh, okay.
But I want to set it up like a quiz because it's a multi-step process. So I want you guys to look at the quote-unquote the first question, which is the first step, and then after you perform the first step, you have to answer a question, and then you move on to the second step and so on. So that's just how I want to set up the homework assignment in stages. Mm-hmm. Right. All right. So the first thing I'm going to do is, to show you guys, at least for those who are interested, how to, set up the live ISO image and, put it onto a single USB drive. This is not the one that you gave me. This is the one that you gave me. So in this case, I'm going to overwrite the entire drive, which is the easiest way to set it up. So what I do is I plug it in. There we go. Okay, right after I plug in the drive, you can open up a terminal in Linux, and I believe this is universal to all distributions now, and type this command called dmessage. And what dmessage does is it will capture all the system messages, and this is the last few messages that pop up. Because I plugged in the drive, it recognizes it as SDD, and it has 8 GB, so I know this is the right drive. And the way we do this to copy the ISO image is to use the command called dd. Now dd is a dangerous command to use. Okay, when you use dd, you specify if to specify the input file. In this case, the input file is the ISO image. The ISO image is located. Let me go to my file manager and have the other drive mounted, because I have it already installed into boot img, boot image. So once I click boot image here, it will be mounted onto the file system, and once it's mounted, it will be under media, under user, because user is the username that I'm using right now, and then it will be under bootimg, which is the name of the label of that partition. And I have the ISO image already stored here, deblive.iso. So that specifies the input file of dd, and then I have to specify the output file. This is where you have to be extra careful, because I'm going to overwrite the entire drive device. Okay, if I specify the wrong one here, I can overwrite the internal hard drive if I had an operating system already installed. It's not just overwriting the master boot record, which is the first 512 bytes. It's going to overwrite the first 2 GB or so. So you will lose content big time if you specify the wrong drive with this command. Okay, but I'm pretty sure SDD is the right drive, just because it is the only 8 GB drive that is currently attached to the system. Yep.
SDD or SDD1?
It's SDD for the entire device. SDD1 is the first partition. SDD2 is the second partition. But I want to overwrite the entire thing, not just one partition.
So it would be SDD.
It would be SDD itself, which is the entire drive, the entire device. So are you absolutely sure that there's no content on that drive that you need to save? All right. Because I just need to double check. Okay. So, I forgot one command, one option that I need to specify. The other option I need to specify here is BS, which is block size. So in this case, I can use a block size of 4 kilobytes. It's basically saying, how many bytes should I try to write to the destination device at once. So this way, it will be writing 4 kilobytes, at once, and it will read and will write the next 4 kilobytes, and so on. It's just speeds up the process quite a bit if you use a larger block size. Okay, so I press the Enter key, and it's working. Now, how do I know it's working, and how long it will take, to run this command? Okay. Let's open up another tab with this terminal. To open a terminal tab, with most terminal programs, you press Ctrl-Shift-T to open up a new tab, or you can just go to File and then say Open Tab here. Okay, it shows you the shortcut key is Shift-Control-T. So this way, now I have 2 terminals, or 2 tabs, currently open, or 3, including the one that is actually doing the screen recording. I will use PS. Do you guys still remember the command PS from last time? Okay. Now PS has many different ways of using it, and one way to use it is to use the -C option. Now that option is particularly useful in this case, because now you can say, okay, give me the process ID of all the programs named DD. Okay, because I'm running DD in the other tab, so this way, I press the Enter key, and it shows me that the only program, the only process corresponding to the program DD has a process ID of 4932. Okay, now that I know the process ID, I can actually poke it. Okay. Now this also looks really dangerous because to poke something, you're going to use the word kill. Okay. Kill in this case is dash USR1 and then the process ID 4932. Okay, I'm just going to press the enter key here, and you will see that over here it doesn't kill the actual process. What it did was to poke at the process and say, okay, report status, tell me what you're doing. That is what dash USR1 is specifying, because it's just a user-defined, what we call a user-defined signal, which is usually it's benign, doesn't do anything. A process can decide to ignore USR1 as a signal. It can basically say, I don't have anything to do, I don't have anything to report. It can just ignore USR1. It does not actually kill the process. Are we doing okay so far with that concept? Now, this particular program, DD, does respond to USR1, and it will just kind of report back, how many bytes have been copied and what is the current speed, because it also knows how much time it has taken up to this point. So for this particular flash device, the write speed is about 5.7 megabytes per second, which is right about the average. Okay, it's not particularly fast, it's not particularly slow either. It's about just about average. If you use an external hard drive, it can go up to maybe 20 megabytes or so, just using USB 2.0. Slower devices can get all the way down to like 2 megabytes per second, so this is actually not slow at all. Are there any questions about what I just did? Okay, if there are no questions, we can, you can poke it as often as you want, but once we know the average write speed, we know that we have another 2.3 gigabytes to go at this point, so it's going to take us another 4 minutes or so. So I know already it's not going to be done anytime soon. It will take another 4 minutes or so. Are there any questions about what I am currently doing to create a USB thumb drive that is bootable? No questions? Okay. All right, so if there are no questions, I'm going to switch back into the notes here and start to basically talk about these topics. We talked about these already on Tuesday, so I'm going to go over this relatively quickly today. We'll start with network ports and connections. This is the long one that we talked about the other day. Remember the analogy of phone numbers, extensions, operators, that sort of thing. So I'm not going to spend too much time to talk about this because we did talk about it already. The next one we kind of talked about, but not particularly in detail. So we'll start with this one. What exactly is a surface when it comes to Linux and operating systems? Let me magnify or change the font size here. The general definition of a surface in the context of Unix and Linux is a program that is waiting for a request to process. Okay, and that's it. A program in execution, to be specific, a process that is waiting for a request. That, by definition, is a surface. Okay, so what kind of surface do you think a system like this has to deal with?
Database servers might have services that fetch information based on what a client needs.
Okay, but that's actually on the database server. Okay, but this class focuses more on the client side. So the question is really asking what kind of surface a client computer actually has to implement.
Within itself?
Within itself.
Okay. There might be a network service that determines timing of sending input-output data.
Okay. Well, there are some surfaces that have nothing to do with networking also. Okay. There are actually quite a few surfaces that are currently being run and active at the same time right now. X window itself is a surface. Okay. Now, what is X window? You're kind of looking at it. Okay. X window is the GUI part of a Linux distribution. Without the GUI part, what do you see? Without the GUI part, you only see the console, and not sure whether the console will show up here because it may not hook up to the secondary display. It does not. Okay, that's okay. Yeah, it does not show up. Okay, I cannot show you the console screen, but I think most of you know what a console screen looks like. It's just a text screen, black and white text, and nothing else. Okay, so that really is the most native form of interacting with Linux. What you're seeing here is implemented by X window. Now, why do you think X window is a surface? And by the way, what exactly is X window? I mean, how is that thing, designed, and how is it supposed to work? Now, X window is separated into two main components. There's an X window server, and there are X window clients. Okay. So for this part, I'm going to draw it on the whiteboard, just because it's a lot faster to draw it that way. Or you can also look up, on the internet. You can look up, X window server client, and once you do the search, look for images, because that's the quick and easy way to find an image that is related to what we are talking about. Okay, such as this one. All right. So, okay. So X window server is a particular program, and X window client is another program. Each one is a process in this case. In other words, it is a program in execution. The X window server is the one that needs to talk to the hardware. Okay, so the X window server is the one that has to have a hardware specific driver. If you use an NVIDIA card, you will need an NVIDIA driver or an NVIDIA specific X window server. If you use Radeon, you will need a driver that is specific to that particular graphics card. So that one is basically saying, okay, I know how to deal with this graphics card. Okay, I know how to draw stuff on the screen. I know how to move stuff around on the screen, but I'm not doing anything because I got nothing to do right now. Nobody is asking me to do anything. That's the X window server. What is an X window client? Everything that you're seeing on screen right now, they are all X window clients. Your browser is an X window client. Your command line terminal is an X window client. Even the desktop itself is an X window client. So what an X window client is a particular application that is supposed to interact with an end user. So when you click on something, okay, so let's switch back into this here. When I type something here, it is supposed to update the screen to reflect what I've just typed. But how is it done? The client program is only responsible of saying, okay, I'm supposed to display OIFJAODIFJ because that's what I just typed. But it doesn't know how to display that stuff on the screen. So all of that stuff translates to requests from the X window client, which in this case is my terminal program, going through potentially a network to an X window server, so it can now be displayed on the machine that is running X window server. Are we doing okay so far? But what about this scenario? If I disconnect the network cable, do you think the terminal itself will still run? Obviously, it will still run, right? Because in this case, these two computers are basically the same computer. But it is a service. X window server is a service, and it runs on a client computer. Okay? Now, to push this argument one step further, why do you think X window is kind of architected this way? Any idea why it is architected this way?
When there were dumb terminals, there used to be a server and a lot of dumb terminals to access it.
Yep, exactly. Okay, and you can still do that to date with X window, with the X window architecture. In other words, if you have one super duper powerful computer at home, you can run all the heavy duty applications on that machine, and you can have a laptop computer with minimal processing power, only acting as an X server in that case. So the client is actually being run on the super duper high power machine, and the server is the one running on your local machine. And that makes sense though, because the X server is the one that is attached to the physical thing that is interacting with the user. The X client, on the other hand, is the one that is doing all the processing. So you want your X client to be running on a super duper server with lots of resources, and you want your X server to be running on a machine that you are actually just using. So it can be a netbook, can be something that has minimal processing power. Okay. So X window is originally architected exactly this way, so that they can make. They used to have diskless X terminals. But they didn't call it X terminals, but they're basically X clients. They should be called X servers, but most people call them X clients, which is kind of like a reversal of the names. But they basically have really inexpensive machines that can be distributed. Like all of these machines here in this lab would be the smaller box, basically this box here, and they will all be connected to a super duper powerful machine sitting somewhere else, and it will host all your files. It will host all the baked programs, and also the mass store on the other device. Okay, but it is a surface waiting for something to happen. All right. Are there any questions about this part of the discussion? What else is a surface on a regular computer running Linux as a client computer? In other words, it's supposed to be an end user computer, not really a computer server. What kind of surface, what other types of surface would you expect?
The surface that receives the input from the keyboard and mouse, or
Okay.
service that looks for updates of the software.
Right. The program that looks for update, it is kind of a surface, but that one is actually active because it is actually actively, based on time, going out and say, okay, should I go for an update or not? Is there an update available or not? What about syslog? In other words, the mechanism that logs all the important system messages. That is actually being run as a surface. Okay. Yep. Go ahead.
Is there a difference between syslog and syslog-d?
Yes. Well, there are. Okay. Syslog is the name of the surface. Syslog-d is the name of the program that is implementing the surface. Because syslog-d, the D stands for Daemon, D-A-E-M-O-N, which is basically a name for a program, a process that has no direct user interaction ability. Okay, because most programs do. Most programs have what we call standard in and standard out, which means you can type something in and they can print something out. But a daemon, on the other hand, has no ability to do that. So there's no direct way for an end user to directly interact with a daemon when it's running. You can only talk to it by sockets, or some other special means to communicate with it. Okay. Now, how do I know there's a syslog-d running in the program? How do I know there's a process corresponding to that particular surface? Well, remember PS? So we can do a ps-c, if I think the name is syslog-d, I can look it up like this. Well, I probably got it wrong. So we'll go ahead and do a ps-uppercase a, lowercase f, and pipe it through less. This is the same command that we ran last time. This will give us, a whole bunch of stuff here. These are all programs. These are all processes currently running or loaded in the system. And now we can look for syslog. And here we have rsyslog-d. That's why it couldn't find it, because there are several alternative implementations of syslog, and with this particular distribution, I use rsyslog-d instead of syslog-d. So that's why the name is a little bit different. There's another one that is definitely a surface. It is called Avahi Daemon. So that's also a daemon, which is a program that is waiting for something to happen, waiting for some request. WinBindD definitely is another one. NMBD is another one. So this particular installation has quite a few surfaces that are currently running. Are there any questions about how to identify processes, and also which program was used to start up a particular process? Because that's basically what we are seeing right now. Okay. Are there any questions? And I think the
Can you do it with the -- forest option that was explained here?
Say again?
There in the text here it talks about forest switch.
Mhm.
You do that.
Absolutely. Now, forest is interesting. The reason why forest is even useful is because a single process can start up other processes. So you can have a process starting another process. If process A starts up process B, process A is quote unquote the parent of process B. Is that okay? So what forest does is it can show you which process starts up which other process. In this case, right here, just on this screen here, you can see that K thread D, which I think stands for kernel thread D, which is the very original, well, not the original, but one of the first few processes to start up, is the parent of all of the other processes that you can see that are quote unquote under it. If you scroll the screen, you can see, right here, this is a complicated tree right here, because we can see that light DM, which stands for light display manager, is starting up the X command. It is also starting up light DM itself, but in a different way, because this one is acting as a session, and it starts up. That one starts up the session manager. The session manager starts up the SSH agent, and you can see the relationship, of all the processes. In this case, we have WinBindD starting up multiple instances of itself, and this is not uncommon that you will see a process starting up instances of itself, especially on a server. Apache is well known to do that. Basically, what it does is it will spin up multiple copies or multiple clones of itself. So when you have requests coming in, it will distribute the requests to different clones of itself so that all of those can be processed at the same time, assuming you have a multi-core processor that can actually do parallel processing at the same time. Are there any questions at this point? And you can see that each login process starts up a bash session. And right here we have XFCE4 panel, which is responsible for this part of the screen as well as this part of the screen. It starts up all the sub panels. In this case, we have a wrapper, and in the other case we also have a wrapper running. I'm trying to find out which. It doesn't have any. It's not corresponding to a particular widget on the bar itself. And then we have PA VU control, which is this program here. Okay, that's the one that we use to control the input channel to the audio recorder. So is that answering your question? Okay. Now, once you know which process starts up which other process, what happens, do you think, when you kill a child process of a parent?
Parent wants a new one.
The parent would know about it, okay, and the parent can decide what to do with it. What happens when you kill the parent process?
Kills all the lower ones?
It will kill all the child processes when you kill the parent process. Sometimes, okay? And what is a zombie process?
It's a child with no parent.
It's a child with no parent, but the child process is not working either. Okay? It's just, you cannot get rid of it in the system, so it's still actually using memory, but it cannot be active anymore because the parent process is gone. Okay? All right. So getting back to the note here. A service is a program that is waiting for a request to process. So it's just waiting for something. And if you think about it, a client computer is for the most part a server. Instead of serving another computer via networking, a client computer serves users via I/O devices. It is seldom that this is really bad grammar here. Must be a really bad night for me. It is seldom that we have processes that initiate actions. More often, processes wait for user input and then respond using some kind of output devices. What does that mean?
It's waiting for us to give it some sort of input.
Yep, exactly. So right now, what do you think, which part of the program or which part of the operating system is waiting for something? Right now, I'm not doing a single thing, and so the mouse is not doing anything. But there is a process that is responsible to look for user events, basically mouse events, keyboard events, and so on. So that is a surface because it is waiting for something to happen. It's waiting for mouse events and keyboard events. So even on the client computer, we do have a lot of surfaces running at the same time, especially when you have a GUI environment running. How do we find all these surfaces? One way to find most of those, not all, but most, is to go to the folder called initd. Okay, initd, this D stands for directory, and init stands for initialization. So let me just go to a text prompt here, or a command line interface, and just take a quick look at what is available in my init.d. And you can see there are quite a few things, and many of these are actually surfaces. Let me see if I can identify a few of these. udev is a surface. It stands for user device. This is actually what is responsible of handling when you plug in a USB device, what driver to load and how to make use of that device is handled by udev. So that one is listening to something, it's waiting for something. What is it waiting for? The event of you plugging in, a new device. Okay. Let's see what else is here. Samba. Samba is another one. Samba is a service because it's waiting for a network connection to say, okay, we want to share something. It's waiting for a request to, access a shared drive or to request to, look at, your shared drives. Let's see. We have MDADM is a if you want to implement software rate, that's what this particular service is for. But since we're not dealing with that, I'm not going to talk about it. Cron is a good one. Okay, what is cron?
Schedules tasks.
It schedules tasks. So what do you think it's waiting for, or what is it listening to? The clock. Yep, the hardware clock or the timer. Okay, to be more specific, it listens to the timer. So it's waiting for a particular time. It goes through all the jobs that it is supposed to do according to a schedule. When it's time to do something, it will start up the process to do that. That is a service. And let's see, we have ulcer. Utils. They correspond to sound resources. So sound card, microphones, they correspond to ulcer. Let's see, networking. Okay, Networkmanager. Networkmanager is the GUI port. Well, it turns into GUI portion of what we usually know as the little icon that let you select which wireless workstation to connect to, that sort of thing, which SSID to connect to if you have wireless. Okay, so all of these are many of these are surfaces. VirtualBox. Why is VirtualBox here? That's the name of a program. What kind of surface do we have associated with VirtualBox? Do you guys remember what we did last time with VirtualBox? We started up a host-only network. That particular network interface is a surface. Okay, it allows multiple virtual machines to connect, quote unquote, connect together through a virtual network. So all of these are basically surfaces, and each one can be started or stopped. Now, how do I know they can be started or stopped? So let me log in as root first, and then we can pick one that is relatively harmless. Okay, I'm going to pick LVM2 here because I'm not using LVM at all. LVM, by the way, stands for Logical Volume Manager. Okay, and it is a particular surface useful for managing your disk and volumes. Okay, we can talk about that later, but right now, I just want to let you see what happens with a surface. So if you just execute these commands without specifying anything else, in this case LVM2, it will basically say you can start it. This one cannot be stopped, so the only thing you can do is to start it. Let's pick one that you can also start and stop. Let's say networking. Okay, I'm not going to stop it because if I stop it, I would lose networking access. But from the command prompt itself, you can see that networking is a service, and what you can do with it is to start it, stop it, reload it, restart it, or to force reload it. Reloading means once you change the configuration file related to networking, you can use reload in order to refresh the surface so it makes use of the updated configuration file. What do you think the networking surface is waiting for?
Something from the NIC.
Something from the NIC. But what can you possibly do to the NIC that is an event that the program can interpret and go like, oh, okay, I got to do something now.
Plug in.
Exactly. Plugging it in and unplugging it, would trigger the networking surface to do something. If you plug in a Ethernet connection, what would happen is it would trigger that particular surface to look up the configuration and decide what to do with that particular Ethernet connection. Okay, is it supposed to be using DHCP? Is it supposed to use static IP? And what to use as the network address and so on? Those are all the things that will automatically be done as soon as you plug in a Ethernet cable to a port that is actually a part of the configuration file. Okay. So getting back to the notes here, and here's the command that I just did a little bit earlier. So there are actually two commands. The first one lists all the processes, and then the second one uses a pager to display the output of the first command so that we can go page up and page down. I'm going to take a little break here, going back to this command, because I'm pretty sure that what we were doing a little bit earlier is now done. In other words, the flash drive is now programmed with the ISO image. How do I test it?
Boot it.
I can boot it, but that means I have to stop the recording and all kinds of stuff like that, which is disruptive. What else can I do?
Can you activate virtual drive and run it through virtual drive?
Exactly. Was that what you were thinking about? See? Virtual machine, exactly. So what I'll do is exactly that. I'm going to use KVM in this case, which is actually QEMU. They went back to the name of QEMU. The two projects, came from the same project, which is QEMU, and then at one point of time, it branched into two different projects. So QEMU, is QEMU, and then somebody took it, into a different branch, a different direction, and called it KVM. And at this point, the two projects got merged again. So KVM is actually a deprecated name for that particular command. It is now, QEMU again. But I think KVM still works. Or not, they completely got rid of that command now. So I have to use QEMU system, and let's use i386 because it can emulate different types of architectures. In this case, I'm just going to use the minimal settings here. So -M512 means I want to only allocate 500 megabytes as RAM, and then I will specify either CD-ROM to the drive that got programmed, or I can specify HDA to specify a hard drive being that device. I can do it either way because that particular image is special. It works as an ISO image to be burned onto a DVD. It also works as an image when you write it directly to a mass store device, which is what the flash drive is. Okay, so it will work in either way. So let's go ahead and try this way. You're using it as HDA. Press the Enter key. It starts up QEMU, and you can see that it's working just fine. Okay, if I go any further, it will start up the entire GUI. So we'll have a GUI inside the GUI, but that is actually proof that it is working. Okay, so let me close this one and unplug it. There's no need to unmount it because I did not mount it into the file system to begin with. So we'll take it off. I have to do it carefully because every single port of that computer is used up. I just have to make sure I don't accidentally ignore it on the cap. Oh, yes I do. Right here. Thank you. Thank you. That's why I use cruisers, that do not have caps. You just kind of slide it, because the first thing I lose is the cap of just about anything. Pens, you name it, I lose the cap first. All right. So now, moving on to a slightly different topic. If you have a larger device, like a 32 gig flash drive, you may not want to waste the entire 32 gig drive just to put a 2.3 gigabyte image on it. Okay, so the other way to do this is slightly more complicated, but it is doable. So let me demonstrate how to do it here. Okay, so I just plug in the device, and the first thing I do is I'm going to use Gparted, which stands for GTK. Is it GNOME or GTK? It's one of those two. Partition editor. So once I start this, it will ask me first for the root password. No, it did not. All right, so now it's up and running. It's a partition editor, which is a very easy way to change partitions layout. You can move partitions, resize partitions, and stuff like that. This is SDA, which is the internal hard drive. So I would much rather not to do anything here. If I use the drop-down box, I can see the other drives. SDB is my cruiser. SDC is my external hard drive, and SDD is the drive that you gave me a little bit earlier. So right now, SDD is showing that it has one single huge partition using FAT32. Okay, FAT32 is good because it's easy to resize. Okay, just about any partition editor knows how to resize FAT32. So the first thing I have to do is to free up some space so I can put the other stuff onto the same drive. So I can click on this one, right click, and say resize/move, and I can use the GUI tool to make it smaller. How much space do you want to reserve for that particular partition?
What I was thinking was have the partition be, well, how much does it usually take up if just a live ISO disk, like 2 gigs?
I would probably reserve 4 gigs for the image itself, and then another 4 or 5 gigs for the, well, actually for the other image, I would reserve about 10.
Just put 25 in there. 25.
25 for.
The.
So shrink this one to how much? Right now it is using.
About half of what's left. A little more. Right there.
Okay, right there. Okay. So I'm going to click this button here. So now we have some space left. Okay. Of the space that is remaining, I can now create a new partition. And the new partition can use, I'm going to use, it's a primary partition. I will use, in this case, NTFS, because I need to store files that are more than 2 gigabytes large. So NTFS is actually required if you want to store something that are 2 gigabytes or larger, which is the image. The ISO image itself is 2.3 gigabytes.
I thought X4 would do the same thing.
It would, but it would make it much harder to update it. So doing it, as NTFS makes it easier to update it later on. Okay. All right, so we'll change this one because I don't need that size. I will give it only about 4 gigabytes. So 4 gigabytes, 4,000 megabytes. That's close enough. And I will label it too. Okay, so we'll label it as ISO images. So this is dedicated to store just ISO images at this partition. And then the last one, I'm going to use it for the persistence portion of the live distribution. So I'm going to right click on this one and then say new again. We can use extension 4, that's fine. But the label has to be persistence. If you want to have a persistence partition, the name has to be persistence itself. Okay. And then we click add. So now I have just made some changes to this whole thing. So what if right now you tell me and say, Tech, I really don't want to do anything to that device. It's not too late. It's actually not too late because all of these operations, they have not happened yet. Okay, so until I click the check mark, nothing is actually being done. It is just I'm just specifying the order of operation of what will be done when I click the check mark, but nothing is actually being done at this point. All right. Okay, so before I click that button, let me just share with you what happened yesterday, and Vincent knows what happened yesterday. Yesterday at about 9:30 or so a.m., there was a campus-wide power fail. And why do you think that's related to what we are doing here?
You were writing an image or that.
Yeah, if you are moving a partition or resizing a partition and we have a power fail, we stand a pretty big chance of actually losing content during that time. So this means if you are doing it on a laptop computer, you're probably better off, because with a laptop computer, assuming you have a healthy battery, it will probably last long enough for the entire operation to finish. If you're doing this on a desktop computer without a UPS, if there's a power fail, it's not a good thing. Okay, so do you still want to do it this way or not?
Do it.
Do it. I like the decisiveness of that.
I
Do
know how
it.
to undo it later, so
See, once you click it, it still gives me one last chance to say no.
do it.
Apply. So now it's actually performing the operation. The first thing it does is to resize the partition. Move the end of the first partition to the beginning a little bit, and then it will create the two other partitions. The resizing part is going to take the most amount of time. And right now, you can actually see the message is checking the file system for errors, and if possible, fix them first. Okay, because there's nothing worse than trying to resize a partition that has a problem within itself already. And it's
Looks like
it's quote unquote stuck right now, because it depends on the flash device. A lot of times, a flash device, a thumb drive, would work like really, really fast for the first few seconds, and then it will go really, really slow. It has to do with a lot of the operations can be done in quote unquote the cache part of it, and that's basically we have used up all the cache or all the cache operation. So now it's it has to do things in a kind of slower way. Now, using this particular program or using PS Forest, we can actually keep an eye on what is happening with that program, because we can look for Gparted. So we can look for ARTED, and here's Gparted, and we can see that Gparted is starting up another process called Gparted bin, and it's starting up another process called Gparted bin. And what I'm trying to do is to find out exactly what is going on right now with that process. So we can also use top. It doesn't look like it's doing anything. So right now, this program doesn't seem to be active at all. It's just, sitting there doing nothing. That's not a good sign.
Now, there's about 10 down, a Gparted bin is popping up. It's come up there.
Oh, okay. Occasionally.
It's using a
It's
little
just
bit of
moving around.
memory.
That means it's probably IO bound at this point. It's limited by how fast things can actually be read from and written to the device.
0.7.
Yeah.
Okay,
FFmpeg is taking up the most resources because FFmpeg is the program that is doing the capturing and also the transcoding on the fly. That's kind of stuff tends to take up a lot of resources. Okay, so we'll give that one a little bit of time to do what it is supposed to, but right now it doesn't seem to be doing anything, and it's supposed to be doing a check disk right now because that's what the message is saying. So I'm not gonna interrupt it at this point, because if I interrupt it, it can actually cause more harm in the process. Right. Any questions at this point? Nope. Okay. Okay, what is a daemon? A daemon, has an explanation here. So I'm gonna right-click and open a new tab for the term daemon. And we'll magnify this a little bit. A daemon is a computer program that runs as a background process instead of being the direct control of an interactive user. That's basically is the definition of a daemon. Traditionally, daemon names end with the letter D, and we saw quite a few of those already. For example, syslogd, or in our case, rsyslogd, is the daemon that implements the system login facility, and SSHD is a daemon that surfaces incoming SSH connections. We saw that last time too. Now, in case you have forgotten what we did last time, let's do it again this time. I'm going to change to administrator account first, and then we can run the same command as last time, which is netstat-tlnp. And right here, you can see that SSHD is the program that is waiting for incoming transmission or incoming connections to any IP address on this computer on port 22. So here comes another question. This one is related to networking. How many IP addresses can be associated with a single computer? So we have a single computer here, a single box. How many IP addresses can this box assume?
One for every network card. Or
One for every NIC?
Yeah.
Okay, so it's limited by the number of NICs. Well, right now there are at least 2 IP addresses corresponding to this computer. Okay, so let's take a look at the command that you can use in order to find out what network devices are now active. It is called ifconfig. Ifconfig is now identifying we have ETH0, which is the Ethernet connection or the NIC Ethernet network interface card. It has an IP address of 165.196.118. And with this number, you guys on your computer can actually make a connection to my machine. Okay. We have another one called LO, which is Loopback. The Loopback device has an IP address of 127.0.0.1, otherwise known as localhost. Okay. And this one is a standard one. Windows machines also have a localhost IP address of 127.0.0.1. Here comes the next question. Can we have multiple IP addresses corresponding to the same network port? So ETH0 is representing one particular jack at the back of the computer. So the question is, can I have multiple IP addresses corresponding to that one single physical jack on the back of the computer? And the answer is
Yes.
the answer is yes. Okay, so that means your computer with only one connection, one physical connection that you can see, can have multiple IP addresses corresponding to it already. And that's why when you read the output of netstat-tlnp, you kind of have to pay attention to this part here. Because if it says 0000, it means it is going to listen to every IP address on this computer, including localhost and also every IP address of every single NIC of this particular computer. Now, how do I know it will even answer to the loopback device, answer to localhost? Well, that's an easy one to fix. That's an easy one to verify. What I need to do is to do SSH localhost, right? Because if I can talk to myself, that means the localhost device is active. It's listening to that port, and it does. Okay. So are there any questions at this point about the relationship between network addresses as opposed to network interface cards, network ports? No questions? Okay. So we are now done with this slide too. We have just explained what is a daemon. And so we are ready to move on to the next one, which is who is listening to which port This is something that we have done already. I just ran the command, netstat-tulnp. The U means UDP. Without the U, if we just specify T, it is just TCP. So now it's listing all the listening ports of TCP as well as UDP if I specify the U here. All right. So we are done with all the topics in topic 2 at this point. When we move on to topic 3, we are going to talk about how to disable ping. What exactly is ping? I mean, you guys know what ping is, but I just want to have you guys explain what is ping.
Ping-f.
Okay, but what does it do?
It's a utility that sends ICMP requests and echoes.
Well, it sends an ICMP request, and then if your computer is not configured to shut up, it will respond with an echo. You basically say, "Yep, I'm here." Okay. So why would you want to disable it?
So that you don't go, "Yep, I'm here," every time.
So people cannot identify that you are here. Go ahead.
I'm gonna say, so somebody could make like a series of virtual machines and ping you a million times at once and bog you down.
Does it give you a lot of protection by disabling ping?
Helps.
It helps a little bit, but not really a whole lot. Okay, because even if you disable ping, they can still scan through all the possible IP addresses to find out what is responding to what type of poking. Okay, so it does give you one level of protection, but not a whole lot, and it doesn't do much if you're standing behind a firewall. Okay, which most of us are. How many people are running naked? In other words, you're connecting your PC directly to the SureWest box or the Comcast box or whatever box that you subscribe to. With some companies, it's not possible anymore. With AT&T, the device that comes with it, has a built-in firewall or built-in router, so you can no longer plug in, naked. But in the past, that used to be, possible. You have a DSL modem that is just nothing more than a modem. So if you connect your computer, your PC, through the Ethernet cable directly to your DSL modem, you are quote unquote running naked. So that means if your computer is not configured to stop responding to ping, any computer on the internet can ping your computer and say, "Hey, IP address so and so, are you there?" And your computer will say, "Yep, I'm here." Okay. So these days with a router, what do you do, to disable ping, effectively disabling ping from the outside world?
It's usually in the setup area.
Of your residential gateway or the router itself. Okay, so it's no longer a Linux topic because your Linux box as a client computer is now sitting behind the firewall. Okay, but what about this computer here? I would let you guys do it. Okay, go ahead and try it. My IP address is 165.196.118. Go ahead, use Windows. Okay, just open up a command line interface in Windows, and then say ping, and then followed by that particular IP address.
It says you have a firewall.
You have a firewall. Is it firewalled?
I'm getting a ping.
So it's not responding?
It's not responding.
Okay.
I mean, it's responding, but
You echoed 4 times.
yeah, it's actually responding.
It might work.
It is not responding? It is responding.
No, you are responding. I just got it.
Yeah. I should be responding. I did not configure this not to respond to pings. Yep. So to disable ping is pretty easy in Linux. So if you click on this slide here, it's a really short slide to talk about how to disable ping. This is one way to disable it. Okay. Let's take a closer look at this command here. Because this command is kind of deceptive, because you would think that disabling ping would require something that tells the operating system to do something. But if you look at this command, what does it actually do? Okay, it is one single command. The first part of the command is echo 1. Echo 1 simply means I want to print a value of 1 to something. Now, if you don't specify anything, let me just do it on the command line here. If you don't specify anything and you just say echo 1, all it does is to print 1 on the command line interface itself. 1. Okay, fine, no big deal. So why would anything like this be able to disable pinging, which is a kind of operating system surface, really kind of deep down in the TCP/IP stack? Well, let's take a look at the second part of this command. The greater than symbol here is called a redirect operator or redirect symbol. What it does is it will redirect the output of the command before this to a particular file. In this case, the command before the greater than symbol is echo 1, which is supposed to print out just 1 itself. So it's redirecting that output, the 1, to the following file. Okay, it can only redirect to a file. If you want to connect 2 programs using one program's output as the input of the other program, you use the pipe symbol, not the greater than symbol. So the second part is nothing more than a path to a particular file. In other words, this is really just an awkward path to a really kind of weird file with a weird name. /proc is the top level folder, and then sys is a folder inside proc, net is a folder inside sys, and so on. In other words, to the command line program here, it is nothing more than a regular file. So how can storing 1 in a particular file be able to do all this magical stuff? In other words, let me just run the command and then I'll have you guys test pinging again. Okay, so we'll go ahead and say echo 1 to /proc/sys/net/ipv4/icmp_echo_ignore all. Okay, I just ran the command. Go ahead and try to ping me again.
We'll make sure.
You are not pinging.
Timed out.
Okay, timeout.
Timed out.
Yep. Wow. Writing a 1 to a file, caused my system not to ping, not to respond to pings anymore. As it turns out, this is no ordinary file. There are several folders that do not store ordinary files. In a normal Linux distribution, /proc is one, /sys is the other one, and then if you look at /dev, those are all special folders. In other words, let's go to /proc now. Okay, I'm going to /proc right now, and I do a ls. I see all these weird file names. Okay, we see file names with numbers as the file name. What do you think these file numbers look like?
Binary stuff
Binary stuff?
or hex.
Look at the process ID here. Just look at about the range of numbers of the process ID. It goes up to about 5,000 something, with a pretty high concentration of 4,400 something. Okay, and I'll do the ls again over here. Do you see a correspondence? Each quote-unquote file, it's actually a folder, is corresponding to a process. If I create a process, there will be a new quote-unquote folder here. Okay. There are also kind of special files too. One other special file is CPU info. Okay, and because it's a file, you can just cat it to look at the content, or use less to take a look at the content. So I can say less CPU info, and it tells me something about the processor that is being run on this, that is installed on this machine. It's an i5 processor running at 3.2 gigahertz, and so on and so forth. Okay. So how did this file come into existence? Maybe when we start up the program, a particular process, take a look at the processor and create this file. Well, that's actually not the case. These files are direct interfaces into the kernel of the operating system. Okay, and this is a very interesting feature of Linux, and also any type of Unix type operating system has this particular attribute, which is they try to look at everything as files. So when you look at that special file that I was accessing earlier, okay, so let's go to that folder here. It's under sysnet IPv4, which is version 4 of the IP Internet Protocol. In this folder, we can see, in addition to the file that we were looking at, we are able to see all kinds of file names that look kind of weird. Okay, so if I go to ICMP, you can see ICMP echo ignore all looks like a single file. Now, if it's a file, I can look at the content of that file using cat. So let's take a look here. Cat ICMP echo ignore all, and it has a value of 1. So this is not a file. This is not really a file that is stored on the disk. This is actually mapping to a particular attribute of a certain aspect of the operating system. When you write to this quote-unquote file, you are actually interacting with the kernel and tell the kernel, hey, I want you to stop responding to ICMP requests. When you cat it, when you try to read that file, you're asking the operating system, what is the current configuration? Are you responding to ping requests? Okay, so these are all very special files that you can use to interact with the operating system. Are there any questions at this point? Nope. Okay, so I'm going to finish this slide relatively quickly. So this one will turn off pinging, but the next time you reboot the machine, it will be responding to ping again. Okay, so you have to do this every single time to stop responding to ping, which is really kind of bothersome because sometimes you forget to do it and now your computer is starting to respond to pings. So if you want to stop responding to pings altogether, and I do not remember to put it here, so I'm gonna have to finish this note here to basically specify what to do to stop responding to pings permanently. There's a way to do it. What surface to turn off and how to turn off the surfaces. And then the last part here is Bastille, which is a hardening program. What it does is it looks at the current configuration of your computer in details, and it will try to identify stuff that can cause security concerns. We're going to do something about this. We'll have a homework assignment to do something with Bastille. But the first thing we need to do is to get VirtualBox installed first. And I'm still running this program. It is not responding. So this is not looking good. I think it's stuck, examining the file, examining the system. So I'm gonna have to, terminate the program.
Let's take a look and see if it's still alive.
I think it's still alive. Sorry.
Had to be somebody's.
The other way to do this, okay, I'm gonna.
Because the program itself looks like it's stalled based on the fact that it didn't die.
Yep, it's still running here. So this is, I can kill it from here. So I'm gonna find the parent of all of them, which is 5140, and kill that one. Kill 5140. Okay, once it's killed, it should be off now.
Well, it should just start up now as normal if you start it.
Nope, the child are still running. The children are still running.
5141 and 5168. Kill 5168.
68.
Alright, now it should do it.
Well, let's double check. Okay, they're all gone. I'm gonna go use another program to check it, which is fdisk. Fdisk is the command line one to look at it. So your FAT32 partition is still here.
So it didn't.
Yeah, it didn't do anything. It could not. It probably just could not finish checking it. It could not even check it. It might have to do with me starting the program not as root, so it was not able to actually check the disk at all. So that means the content is still here.
That's why that's why it froze right at the very beginning instead of.
Right.
Well, do you have any time?
Well, I have no time right now because I have another class coming up. So I'm gonna stop the recording at this point, and then over the weekend, I will give you guys some additional stuff to do. And as far as you're concerned, you can. Okay, we'll talk about this, of what to do with your particular case. Does anyone else have a problem with a VirtualBox? Nope. Okay. So once we have VirtualBox up and running, we can start to do some experiments.
Does